value of money. Suppose your friend tells you that after 5 years he would have 15 lakhs in his account. You are really surprised by this and you become curious to know that what is the current value in his account. So this is an example where we want to find the present value before 5 years, right? So after 5 years his account would have 15 lakhs, but we want to know the present value before 5 years from the future value. That is, we want to calculate the present value. So we have already seen in the first video that the formula for future value is P into 1 plus R by M raised to the power M into N. The same formula can be used to calculate the present value. If we tweak it a little bit, we get present value equal to future value divided by 1 plus R by M raised to the power M into N. Right. Where P is the present value, FV is the future value, R is the rate of interest per annum, N is the number of years, and M is the compounding frequency depending upon whether it is annual, semi-annual or quarterly. Let's try to understand the present value of money using an example. You are valuing a project that is expected to run for 5 years and is expected to give you one-time cash flow of $500 million after 5 years. Right. So basically the project is expected to run for 5 years, and after 5 years it is expected that project will give you back $500 million. You estimate a discount rate of 11%. What is the present value of cash flow? Right. So discount rate is given to be 11% and you have to calculate what is the present value of the cash flow. Which cash flow? This cash flow that you will get after 5 years, that is $500 million. So if you analyze the problem, eventually it becomes that after 5 years you will get $500 million and you have to find the present value. That is, you have to find the present value 5 years before, then you will get 500 million, right? So it becomes something like this, that you can use this by using the formula P equal to future value divided by 1 plus R by M raised to the power M into N, where P is, you have to find future value is given to be 500 million, R is 11%, discount rate is given to be 11%, so that becomes your R, and N is 5, right? Because 500 million you will get after 5 years, so the present value has to be found out 5 years before when you get 500 million. So N becomes 5 year, right? And M is 1 because we are assuming the annual compounding here, right? So when you put all these values in this formula, you will get P equal to 500, that is future value, divided by 1 plus 0.11, that is the rate of interest, divided by M, which is 1, the whole raised to the power M into N, that is 1 into 5, because M is 1, N is 5. And when you solve this, you will get your value as 296.73, that is present value of 500 million that you will get after 5 years. Right now, as of today, is 296.73. Now let's try to understand how can we find present value of annuity. We already discussed in the first video that annuities are something in which same amount of investment is done at the end of each year for certain number of years. So this is the annuity on your screen and you need to find its present value. One way can be that you find the present value of all the investments independently. This would be a very complex and tedious way, but this can be used to find the present value. Once you find the present value of all these investments, you can sum this up to find the present value of the annuity, which will come out to be 4329.48. But let's see what can be the easy way or which formula can be used to find the present value of annuity. Well, this is the formula on your screen which you can use to find the present value of annuity. The formula is C into 1 minus 1 plus I raised to the power minus N divided by I. C is the cash flow or the investment done at the end of each year. I is the interest rate, N is the number of payments, and PV is the present value of the annuity. We can also call it P. Now let's try to solve our example using the formula. So this is our example of annuity where $1,000 is being invested at the end of each years for next 5 years and the rate of interest is 5%. And now we use this formula to find the present value of annuity. we get C equal to 1000, that is the value invested at the end of each year, I equal to 5%, which is rate of interest, and N equal to 5, which is the number of payments or number of periods. When we put these values in this formula, we get this PV equal to 1000, which is your cash flow, into 1 minus 1 plus 0.05, which is your rate of interest, or I raised to the power minus 5, which is N, divided by 0.05, which is I. And you will get PV equal to 4329.48. You can also solve by yourselves and try to match your answer with our answer. Now let's see how can we calculate the present value of annuity due. Again, we discussed in video number 1, annuity dues are something in which investments, or rather same investments, are done at the start of each year for a certain number of years. Here rupees 1000 or $1000 is being invested at the start of each year for 5 years, and we need to find out the present value of all these investments. Again, a tedious and complex way to find out this would be to find out the present value of all these investments independently and then sum this up. The answer would come out to be 4545.95. You can try this out. At least this will help you to practice something. But what could be the easy way, or which formula can be used to find the present value of annuity due? Let's see. So the formula which we can use to find the present value of annuity due is C into 1 minus 1 plus I raised to the power minus N divided by I into 1 plus I. So this formula is almost similar to the present value of annuity, except that this has an additional factor, rather multiplication factor of 1 plus I. So if you multiply the formula of present value of annuity with 1 plus I, you will get the formula for present value of annuity due. C here is cash flow, I is interest rate, N is number of payments, and P is present value. So let's try to understand the present value of money for an annuity due using an example. So this is your annuity where you are investing $1000, right, for 5 years. That is 1000 is being invested at the start of the year for next 5 years, and the rate of interest is 5%. So you have to find the present value of these cash flows. So this is the formula for present value of annuity due, right? And using this formula, if we put the values, we will get the result. C in this formula would be 1000, that is your amount which is being invested in annuity due, right? I, that is rate of interest, would be 5%, and N, that is the duration of this annuity, would be 5 years. If you put this value in this formula, C is 1000, I is 5%, that is 0.05, N is 5 years, your equation will become something like this. 1000, that is C into 1 minus 1 plus I, that is 1 plus 0.05 raised to the power minus N, which is minus 5, divided by I, which is 0.05, into I 1 plus I, which is 1 plus 0.05. And if you solve this, you will get your result, that is present value of this cash flow is 4545.95, right? So I hope you can also get the same result and you have understood about the present value of annuity due. Let's do a concept check. Ram and Shyam are two friends. They both have properties which have been given on rent. So Ram and Shyam both have given their properties on rent. Ram gets the rent at the start of each month and Shyam gets the rent at end of each month, right? So if both of them get the same rent each month for next 5 years, then whose present value of money would be more? So basically Ram is getting the rent at start of each month and Shyam is getting the rent at the end of each month. Now the question is, if both of them get the same rent for next 5 years, whose present value of rent would be more? And you have to assume that the discount rate is 10%. Now please try to understand here, we need not solve this. We have discussed about the present value of annuity and present value of annuity due. Ram is getting rent at the start of each month, which is annuity due. So we know that Ram's present value would be present value of annuity due. Shyam is getting the rent at the end of each month, so Shyam's present value would be present value of annuity. And we know that in present value of annuity due, there is an additional factor of 1 plus I, right, which gets multiplied. So for annuity due, the present value would be more. And who is getting the annuity due? Ram is getting the rent as annuity due. So the present value of Ram's rent would be more. In other way, you can say, see, if you get certain value after 5 years, its present value would be less, then if you get a certain value after 3 years. So the longer the period for which you are calculating the present value, the lesser would be the present value. In annuity due, you are getting it at the start of each month, right? Whereas in annuity you are getting it at the end of each year. So in annuity due, I mean, the period for which you are calculating the present value is less because it starts at the start of each month. In that way also, since the period for which you are calculating the present value is lesser for annuity due, so the present value in case of annuity due would be more, right? So in this case, the answer would be Ram. Let's study the rule of 72 now. What is rule of 72? First of all, rule of 72 is a very interesting method, is a shortcut method. If you want to estimate that how many years it would take to double your money for a specific rate of interest, right? So rule of 72 is a shortcut method which helps you estimate that what shall be the number of years in which your money will get doubled at any given annual rate of return, right? So let's try to understand this with an example. Let's try to understand this with an example. Suppose you want to double your money from 100 to 200 and you want to know that how many years would it take at 8% rate of interest. Let's try to do this with the traditional method first, and then we will see how rule of 72 helps us. So with traditional method, you can solve this by using the formula of future value equal to present value 1 plus r by m raised to the power m into n. Here future value would be 200, the present value would be 100, m equal to 1 assuming annual compounding, n that is the number of years we have to find out, and r is 8%, that is rate of interest. When we put these values in this formula, what we get is 200 equal to 100 into 1 plus 0.08 raised to the power n. And when you try to solve this, it is very difficult to find the value of n. You have to use some logarithmic fundas to find this out. But let's see how can we find this very easily by using rule of 72. Rule of 72 says that to find out the number of years which would be required to double the money, you just divide 72 by the rate of interest. So here you will divide 72 by 8, which is your rate of interest, and the answer would be 9 years. That is, you can double your money at 8% rate of interest in 9 years. Irrespective of the fact whether your starting amount is 100 or 1000 or 10,000 or 1 lakh, it will always take 9 years to double your money at 8% rate of interest. What is rule of 144? Rule of 144 basically says how much time it will take you to quadruple your money. Suppose you want to convert 100 into 400, then at 8% rate of interest, it will take you 144 divided by 8, that is 18 years. Let's see how does rule of 114 works. Rule of 114 basically helps you to find out the time required to triple your money at a certain rate of interest. If your rate of interest is 8%, then the time required to triple your money would be 114 divided by 8 equal to 14.25 years. Now just to sum up, you can already see that how easy these rules are, and in comparison with traditional methods, they will help you save a lot of time, and sometimes you will never be able to solve the question with traditional method, but it will just take you seconds to solve them with a rule of 72, 144 or 114. Now let us discuss what effective rate of interest means. Suppose you have a starting value of 100, the interest rate is 14% per annum, which is compounded semi-annually, and you want to find the future value. So the interest rate for first 6 months would be 100 into 0.07 equal to 7. We have taken it 0.07 here because the total interest rate for an year is 14%. So for half year, the interest rate would be halved. So we will take 14 by 2, which is 7%, and 7% becomes 0.07. So the interest for first 6 months is 7. Interest from 6 months to 12 months would be 100 plus 7. This 7 is the interest for first 6 months into 0.07, which will come out to be 7.49. The total interest would be 7 plus 7.49, which is equal to 14.49. So effectively what you are getting is you are getting an interest of 14.49 when you invest rupees 100. So your effective rate of interest is 14.49%. That is 14% compounded semi-annually would be equal to 14.49% as a simple interest. Now what is the formula to find out effective interest rate? The formula is on a screen. Effective interest rate is equal to 1 plus R by M raised to the power M minus 1, where EIR is the effective rate of interest, R is the nominal or the yearly interest rate, and M is the frequency of compounding per year. Now let's try to solve this example with this formula and find out that indeed this formula works or not. So when we put the values in this formula, we get EIR equal to 1 plus 0.14, which is the rate of interest, divided by 2, which is M, that is the compounding frequency, raised to the power 2, which is again M, and it's 2, minus 1. So the answer when you solve this would be 14.49%, which is same as the answer we got in the previous slide. So indeed, this is the correct formula to find the effective interest rate. So what are present value factors? Present value factors again helps you minimize your calculation when you are solving a numerical. Present factor values basically helps us that what shall be the present value of rupee 1. I repeat, what shall be the present value of rupee 1 that you will get after certain number of years, assuming a certain discount rate. Assume that you will get rupee 1 after 5 years. Assume you will get rupee 1 after 5 years and the discount rate that you have to use is 12%. Then you use this row and you use this column. You will get your answer that present value of rupee 1 that you will get after 5 years and at a discounting rate of 12% would be 0.567. Similarly, let me tell you one more example. Tell me what shall be the present value of rupee 1 that you will get after 15 years assuming 8% rate of return. So present value of rupee 1 that you will get after 15 years, it means this row here, right? And the discount rate that you have to assume is 8%. This means this column, right? So this is the intersecting point. So present value of rupee 1 that you will get after 15 years at 8% rate of interest would be 0.315. So using this table, you can calculate the present value of rupee 1 that you are supposed to get after certain number of years, that is an year, and assuming a certain rate of interest, that is R here, right? So this is the kind of table that is used to find the present value of rupee 1 for a certain duration at a certain rate of interest. Right here, this is a very simple view of present value factor table. Otherwise, it is very detailed. We have n here is as 1, 2, 3, 4, 5. Right here, some values are missing 6, 7, 8. But in actual present value factor table, you will even get 6, 7, 8, 10, 11, 12 like this. And the rate of interest will also be each one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like this it will go. So using that you can calculate the present value of rupee 1 for any duration n, right, and for any rate of interest r, right. And you need not mark this up. Either these present value factors will be given in the questions itself, or you will be given a booklet using which you can find out this present value factors. So let's try to see how can we use present value factors in a question. Suppose you are valuing a project which is supposed to run for 5 years, and after 5 years you will get $500 of cash flow that you will get after 5 years, and the discount rate is given to be 12%. You have to find the present value of this cash flow, that is of $500 million after 5 years. So one is that you can solve this using a normal method where you can find present value equal to future value divided by 1 plus R by M raised to the power M into N. R is 12%, N is 5 years, right? You put these values, right? 500 divided by 1 plus 0.12 divided by 1 raised to the power M into N, that is 1 into 5, you will get 284.09. Now we can also use it, we can also solve it using present value factor method rather. We know We just discussed in the previous slide that present value of rupee 1 that you will get after 5 years at a discount rate of 12% is 0.567. So present value of rupee 1 is 0.567 when n equal to 5 and interest rate equal to 12%. So present value of $500, or we will assume that it is rupee 500 only. So present value of 500 would be 500 into 0.567. For rupee 1 it is 0.567. So for 500 it would be 500 into 0.567, that is 283.5. Right. So when we solve this using present value factor, it becomes very easy, and the answer we get is 283.5. Now you must be seeing that there is some difference between when we solve it by actual method and by present value factor. That is, here the answer is coming as 284.09 and here it is coming as 283.5. The answer is that we have used this 0.567 up to 3 decimal places only. If we use it up to 4 or 5 decimal places, then we will get more accurate answer, right? So the more number of decimal places we use in the present value factor, the accurate will be our answer. Similarly, the future value factors help you know that what would be the future value of rupee 1 after a certain number of years at a certain interest rate. Let's try to understand this also with an example. Suppose you have rupee 1 today and you want to know its future value after 5 years at 12% rate of interest. So by this table, you can easily get to know that the future value of rupee 1 after 5 years at 12% rate of interest would be 1.762. Right. And similarly, if you want to find out the future value of rupees 100 after 5 years at 12% rate of interest, then you just need to multiply 100 by 1.762. Let's try to understand the future value factors using an example. Suppose at the time of your birth, 25 years ago, your father deposited 1200 in an account at an annual interest rate of 15%. So 25 years ago, the money deposited is 1200, right? And the annual rate of interest is 15%. Now the question is, how much money would exist in that account today, assuming annual compounding? That is, what shall be the value today after 25 years it was deposited? And we have to assume that it is annual compounding, and the future value factor for 25 years at 15% interest rate is 32.91. That is, value of rupee 1 after 25 years at an interest rate of 15% will be 32.91. So we are given a value of rupee 1 after 25 years at 15% rate of interest is 32.91. So it's very easy to find out what shall be the future value of rupees 1200 after 25 years at rate of 15%. It's very easy. For 1 it is 32.91. For 1200 it would be 1200 into 32.91. That is 39502.74. Right? So future value of money in this question, when we find out using future value factors, would be 39502.74. Now let's try to understand what do we mean by present value annuity factors. Present value annuity factors gives you the present value of 1 unit of annuity for a combination of years and interest rates. Now let's try to understand this with an example. Suppose you are about to get rupee 1 for next 5 years at the end of each year, and the discount rate you are assuming is 5%. Then the present value of all those cash flows that you will get for next 5 years at the end of each year would be 4.32948 here. Right. So like this, you can find the present value of annuity of rupee 1 for any combination of n or interest rates. Let's try to understand how can we use the present value annuity factor with an example. You have to find what is the present value if the project which pays a cash flow of 1000 per year for each year for next 5 years, assuming the rate to be 5%. That is, you have to find the present value of annuity of rupees 1000. The interest rate is assumed to be 5% and the duration is assumed to be 5 years. And it's given in the question that assume that the present value annuity factors for 5 years at 5% rate of interest is 4.329. So here directly you can find the present value by multiplying 1000 by present value annuity factor for 5 years at 5% rate of interest, which is given as 4.329. So your answer would come out to be 4329. Now let's discuss what does future value of annuity factor means. On the similar lines, what we discussed in present value of annuity factor, future value annuity factors gives you the future value of 1 unit of annuity for a combination of years and interest rates. Let's try to understand again this with an example. Suppose you are about to invest rupee 1 for next 5 years at an interest rate of 5%, then the future value factor for this annuity of rupee 1 would be 5.526. That is at the intersection of 5% and 5 years. Right. Let's see how can we use the future value annuity factor in a question. Suppose you invest 1000 at the end of each year for next 5 years and the interest rate is supposed to be 5%. Now you have to find what shall be the total value of money at the end of 5 years. You are investing 1000 at the end of each year for next 5 years. The interest rate is assumed to be 5%. You have to tell me that what would be the total value of money at the end of 5 years. And you have to assume that future value annuity factor for 5 years at 5% rate of interest is 5.526. That is, if you invest rupee 1 at the end of each year for next 5 years at 5% rate of interest, its value would be 5.5256. Right. So the solution is very easy. The value of rupee 1 annuity for 5 years at 5% is 5.5256. So the value of rupees 100 annuity for next 5 years would be, rupees 1000 annuity for next 5 years would be 1000 into future value annuity factor for 5 years